Imagine an airplane so sleek and glamorous it became the status symbol of post-war America, and at the same time quietly racked up one of the worst in-flight breakup records in general aviation. The V-tail Bonanza wasn't just another four-seat single. It was the airplane you bought when you'd made it. The one on the magazine covers, the one in the ads, the one doctors and lawyers ordered like a new Cadillac. And for thousands of owners, it delivered exactly what it promised: speed, comfort, and that unmistakable butterfly tail flashing on the ramp. But behind the legend was a very awkward statistic. By the late 1970s, more than 200 V-tail Bonanzas were known to have come apart in flight, almost all fatals, while the straight-tail Bonanzas had logged only a single structural breakup. The FAA, NTSB, and even Beech's own engineers had been quietly tracking that pattern for decades. So how did one of the most successful light aircraft ever built end up with that kind of shadow over its name? The Bonanza was the brainchild of Ralph Mervyn Harmon. Harmon wasn't some corporate paper pusher who lucked into a chief designer title. He'd been building airplanes since he was a teenager in Indianapolis, where he designed and flew his own Ford Model A powered home-built in the early 1930s. By 1939, Beech had hired him as a draftsman, and he worked his way up to chief design engineer and assistant chief engineer, cutting his teeth on tough wartime projects like the XA-38 Grizzly attack aircraft, alongside a small group of hardcore engineers in Wichita. When the war ended, Beech management gave Harmon an ambitious brief: design a four-seat airplane that would carry people in car-like comfort but fly faster and look more modern than anything on the ramp. One day, as Harmon later told it, one of the engineers walked in at lunch with a Polish aviation magazine. Inside was a sketch of a V-tail design. "That's the kind of tail you ought to put on your new airplane," the engineer joked. It fit perfectly with Harmon's push for something new, different, and better, so he literally had an artist draw a Bonanza with a V-tail and sold management on the look. The result was the Model 35. Slim fuselage, sexy swept leading edge, and that twin-fin tail canted up into a V. Beech PR called it the butterfly tail, and at one point even claimed they'd use it on all their future designs. That didn't happen. The Bonanza would be the first and last Beech with a V-tail, but as a piece of styling, it was a masterstroke. The idea behind a V-tail on paper sounds clever. Instead of using one vertical and one horizontal surface, you tilt two tail surfaces upward and let them do both jobs. On paper, you get less drag and less weight. To better understand how V-tail works, let's compare a traditional tail airplane to one with a V-tail. Traditional tail setup is a horizontal stabilizer with elevator and vertical stabilizer with rudder. In a V-tail, there are the stabilizers with rudder vators. To pitch the airplane up in a traditional tail, the elevator moves up, resulting in a downforce, which makes the airplane pitch up. In the V-tail, the rudder vators also deflect upward, which makes the airplane pitch up. But to yaw the airplane to the right in a traditional tail, rudder moves right and we get a force like this, which makes the airplane yaw to the right. But on the V-tail, the right rudder vator goes downward and the left one goes upward, which gives us these forces, and the resultant force ends up like this, and the airplane yaws to the right. To combined pitch and yaw, I mean to pitch up and yaw to the right, a traditional tail will move the elevator up, giving us this force, and the rudder goes right, and then there's that force, and the resultant force is like this, and the airplane pitches up and yaws to the right. But on a V-tail, the right rudder vator remains neutral, and the left rudder vator moves upward, giving us this force, so the airplane pitches up and yaws to the right. This looks straightforward on paper, but in reality, it is extremely messy. To get the same stability and control, those two surfaces have to be significantly larger than a conventional tail. A complex mixer is needed to turn pilot inputs into the right blend of pitch and yaw, and because the two rudder vators can't be mechanically tied together like normal elevators, you need aggressive mass balancing to keep them from fluttering themselves to pieces. There's even a good argument that when you include trim drag, a V-tail can end up more draggy than a straight tail. But none of that mattered in 1947. The public saw style, speed, and a futuristic tail straight off a jet fighter. Beech saw orders, and for a while, everyone was happy. The Bonanza became the post-war status symbol. The brochures showed well-dressed couples stepping out of their V-tails like movie stars. Magazine ads parked it next to Cadillacs and country clubs. FBOs joked that you could tell who'd made partner by the butterfly tail on the ramp. Underneath the shine, though, the airplane had been drawn right up against the edge of the rulebook. The early straight 35s were engineered to meet the old Civil Air Regulations Part 3 loads with very little extra. Beech wanted speed, useful load, and that smooth Beechcraft feel, so every pound of structure counted. The wing carried its loads efficiently, but out near a point engineers called Wing Station 66, there was a structural joint that did a lot of work in a very small space. When the first serious accident started rolling in, that is where the wing liked to let go. The warning shot came early. In 1946, during certification, a Bonanza prototype went into a high-speed dive test and never came back in one piece. The observer bailed out and survived, but the test pilot did not make it. Beech engineers evaluated everything and strengthened the structure, so on paper, the airplane met the code, and it was a hit on the marketplace. But in real world, a pattern began to form. Year after year, Bonanzas are breaking up mid-flight, mostly in bad weather, and most of those are V-tails. As the fleet grew through the 50s and 60s, the numbers stopped looking like bad luck and started looking like a trend. By the late 1970s, more than 200 V-tail Bonanzas were known to have come apart in the air, almost always with no survivors. Over the same span, the straight-tail Bonanzas had suffered only a single structural failure. It is worth noting that both the straight-tail and the V-tail share the same basic fuselage, but the records are very different. Insurance people started calling it the doctor killer, and the stereotype was a wealthy owner with marginal IFR currency blasting off into a winter front, losing control in the clouds and overstressing the airplane on the way down. There was some truth in the profile because a lot of Bonanza owners were doctors, lawyers, and business people, and many of the breakups happened in cloud, at night, or in ugly turbulence. But the nickname glossed over something more uncomfortable. If the problem lived only in the cockpit, the straight-tails should have shared the same fate. They did not. The real story lives in three places. 1. The tail. 2. The way the airplane behaves when you stop paying attention. And 3. The way people load it. You've already seen how the V-tail works in theory. 2 ruddervators, a mixer that blends your pitch and yaw inputs into the right combination of together and differential movement. On the drawings, it's clever. In metal, it creates a very demanding piece of hardware. Each ruddervator has to do elevator duty and rudder duty. Each one hangs out in the breeze on its own. You can't just bolt the 2 sides together and call them one elevator. That means each surface needs very careful mass balancing to keep it from fluttering as speed goes up. The trim system uses little tabs on the trailing edge, driven by cables running back through the tail cone. As long as everything stays tight and clean, it works. Now fast forward 30 years. Those trim cables have been sitting unseen in the tail cone, exposed to moisture, exhaust, and constant vibration. Some corroding and others wearing where a mechanic once pulled a bolt a little too tight through the eye. Strands breaking one by one while the trim still feels normal and the airplane still flies, even though the safety margin against flutter is now far thinner than the drawings ever assumed. Engineers calculated that if a ruddervator trim tab on a Bonanza comes loose and goes free, it can start to flutter at just over 100 miles an hour and destroy itself a knot or 2 faster. That's well inside the normal flight envelope. The airplane gives you almost no warning. A casual vibration turns into a blur, a surface tears off, loads spike through the tail and into the fuselage. By the time the pilot even understands something is wrong, the structure is already breaking. Not every breakup started with flutter. Some started with the way the Bonanza moves in rough air. Those that have flown a V-tail in turbulence describe a waggle, where the tail rocks, the nose yaws and rolls in a quick side-to-side motion. Technically, it's Dutch roll, a natural mode where yaw and roll couple together. In the Bonanza, it has a period of about 2 seconds. That's just long enough to tempt the pilot to help with the rudder, and just short enough that those stabs at the pedals usually arrive out of phase and make the motion worse. In the 1960s, NASA borrowed an S-35 Bonanza for a general aviation handling qualities study. A test pilot who later flew Apollo 13 put it through its paces. At higher speeds in rough air, the Dutch roll got strong enough that he worried about exceeding structural loads if he tried to hold the airplane steady with his feet. That was with a professional test pilot who knew exactly what he was looking at. For a tired owner pilot in winter weather, the workload can climb very quickly. The other dynamic quirk hides in the spiral mode. Left alone in IMC with no trim changes and no control inputs, the Bonanza doesn't hold level but slowly slides into its preferred turn, a shallow bank building almost unnoticed as the nose eases down, the speed comes up, and the bank tightens into a full spiral. One airline captain who used his N-model Bonanza as a commuter told how, in cloud, he bent down for just a few seconds to grab an approach plate off the right seat and looked back up to find the attitude indicator showing about 40 degrees of bank and 30 degrees nose low, the airspeed racing toward the red line, and the altimeter unwinding. He hadn't yanked the airplane into anything. He had simply let go long enough for the Bonanza's natural spiral to take over. The Bonanza's light ailerons and, on earlier models, lack of aileron trim make this easier to trigger. The simple weight of a hand draped on the yoke can apply enough roll input to start a bank if the airplane is even slightly out of lateral trim. In clear air with a sharp pilot, that never becomes more than a gentle drift you casually correct. In cloud, at night, while changing a frequency or hunting for a chart, it can quietly build into a high-speed dive. There is one more ingredient that makes that dive especially dangerous. It's where the weight sits. On paper, the V-tail and straight-tail Bonanzas look very similar in center of gravity range. In practice, the V-tail's aft limit is a little farther forward. Load the same family, same bags, same fuel, and the straight-tail will often sit comfortably in the middle of its envelope while the V-tail creeps back toward the aft edge. Owners who never run a detailed weight and balance calculation can push behind the legal limit without realizing it. An aft CG reduces pitch stability. The nose wants to wander more in turbulence. Control forces get lighter. In that high-speed dive, a small backward pull on the yoke makes a big change in angle of attack. A sharp pull from a startled pilot can drive the airplane straight past its limit load before they even process what's happening. Put all of this together, and a typical breakup chain looks depressingly consistent. The airplane is loaded near the aft CG limit, the pilot launches into marginal weather, somewhere along the way there is ice, turbulence, a system failure, or simple disorientation, the Bonanza slips into a spiral, the nose drops, speed builds quickly because it is a clean retractable, the startled pilot hauls on the yoke, the tail and wings see more G than they were ever meant to carry, with a V-tail flutter boundary now closer than it was in 1947, thanks to age and wear. The structure finally lets go, and what follows is just wreckage. One accident near the Pass, Manitoba, in the early 70s shows the pattern in sharp outline. A turbocharged V-tail lost its primary gyro source in instrument conditions. In the confusion that followed, the airplane stalled and then pitched over into a very steep, very fast dive. At some point in that plunge, the right rudder vader departed. The nose dropped farther. Moments later, the left wing failed, the engine tore free, and the remaining structure came apart. Investigators reconstructed the trajectory and found nothing exotic in the control inputs. A runaway spiral, a panicked pull, and an airframe pushed beyond its limits were enough. To their credit, Beech's engineers did not ignore the data. Over the life of the Model 35 series, they thickened skins, reinforced wing structure, and redesigned tail attachments. The H model represented a major structural upgrade. Later V-tails, such as the V35B, have a much better record than the very early straight 35s. Regulators layered on their own fixes. Airworthiness directives called for inspections of fuselage bulkheads in the tail cone, checks on the carry-through structure where the wings meet, and careful balancing of the rudder vaders. Advisory circulars and maintenance alerts reminded shops to look hard at trim cables and fittings in the tail. At the same time, Beech quietly offered customers a way to get Bonanza performance without a butterfly tail. In 1960, the company rolled out the Model 33, essentially a Bonanza fuselage with a conventional tail. 8 years later came the stretched Model 36. Those airplanes share the Bonanza's speed and comfort, but show almost none of the structural failure history that haunts the V-tail. Inside the company, there were even studies of a straight-tailed Bonanza that would have replaced the V-tail entirely, and the performance estimates for that version actually came out slightly better than the production figures for the equivalent V-tail model. So on paper, the engineering case for a conventional tail was strong, but the marketing appeal of the butterfly silhouette was stronger, and the V-tail stayed on the brochure. So, where does that leave the airplane today? For many owners, the V-tail Bonanza is exactly what it looked like in those early ads. A fast, comfortable, four-place traveler with Beechcraft quality and a bit of ramp drama built in. Flown within its envelope, maintained with respect for the tail, and handled conservatively in weather, it gives thousands of hours of uneventful service. The pilots who know it well treat it as a thoroughbred. They calculate weight and balance carefully and keep the CG forward when they can. They slow to maneuvering speed or below in serious turbulence instead of blasting through at cruise. They stay current on instruments and think twice before pressing into convective weather or embedded icing in a slick, high-performance single with no second engine and limited structural margin. On the maintenance side, careful owners pay close attention to the tail cone. They replace trim cables instead of trying to squeeze one more annual out of them. They insist on proper rudder vader balancing and stay on top of service bulletins, not just minimum legal inspections. Many fit yaw dampers, or at least simple wing levelers to take some workload off the pilot and tame the Dutch roll in rough air. The result is a fleet that is both safer than it used to be and still carrying a lot of history in those two angled surfaces. Look at a V-tail Bonanza on the ramp today and you still see the post-war optimism baked into its lines. You see Ralph Harmon's team trying to leapfrog a generation of fabric-covered tail draggers in one jump. You see Beechcraft's marketing department betting big on a silhouette you could recognize from across the airport. You also see decades of accident reports, structural upgrades, service letters, and hard-earned lessons about how far you can push an elegant design before physics catches up. The butterfly tail turned the Bonanza into an icon. It also forced the entire community to confront how small design choices, pilot habits, and aging structure interact over tens of thousands of flight hours. For some, that history is a red flag. For others, it is part of the airplane's appeal. Either way, when that V-tail flashes in the sun and the Bonanza lifts off yet again, it carries more than 4 people and some luggage. It carries a complicated story of style, engineering, and consequences written into every rivet of that shimmering V. So that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.